Okay, everyone, welcome to our seminar, which is the last of this year's academic year's seminars. So thank you for turning up today, and also for turning up in various bits of the whole series. And we have a whole new series starting in late September and carrying on. They already got a really exciting range of speakers lined up for those months. And it gives me great pleasure to introduce our speaker, Sebastian Steibl, who is visiting us for a couple of weeks. He's been here for the last few weeks. He's leaving tomorrow, and he's a postdoctoral researcher at the University of Auckland in New Zealand. And he did his undergraduate degree and his PhD at the University of Bayreuth in Germany, and a lot of that work's been on atolls. So he's been thinking about atolls for quite a while, and we'll share some of his ideas and thoughts about that. So thank you for presenting to us. Over to you.
Thank you. All right. I'll give a few seconds. Let's be coming. So thank you, Yadvinder. Thank you, everyone. I'm very excited to be here and speak a little bit about sort of the system that I'm very excited about, and I'm very happy to present to you in a very broad sense the ecology and also the conservation of atolls. And this work is basically bringing together two major pieces of work that I've been writing. One is a big review on atolls that's going to be published later this year in annual reviews, that's sort of looking back at all of what we know sort of about atolls. And then the second bit, the conservation bit, is an article that we've written that's more looking to the future, how we think we should approach atolls beyond this very fatalistic narrative that we have about these systems. But to begin with, I really just want to make sure that we're all on the same page here. When I speak about an atoll, I mean these large circular or ring-like structures in the tropical oceans, and they really comprise three major subsystems or three components. We have the coral reefs that form these more or less continuous rings. On top of these coral reefs, we find the islands. There could be one, or as you can see here, many different islands. And in the center, this ring encloses a lagoon. And really, these three subsystems or these three components together make up what I'd define as the whole atoll. And these atolls, they come in quite a variety, in a diversity of appearances. We can have atolls that are essentially a completely closed island ring here to the left. We can have atolls where the coral reefs are continuous, but we have sort of the islands or the landforms separated by channels. The coral reefs can also be separated in itself, so we have these large channels. And there's actually, at least in parts of the Pacific, a situation where these whole structures are somewhat tilted and they appear more like lines. But if we have this satellite look on them, we can still see the general atoll morphology. And even though we sometimes think of these atolls as a very odd and rare and maybe exotic, even though I don't like the word, ecosystem, they're actually quite widespread. If we map out all the oceanic islands across the Indo-Pacific, we realize that about a third of the Indo-Pacific islands that we have are atolls. And in regions like Polynesia, but also the Western Indian Ocean, atolls actually make up the most common and the most dominant island type, at least by numbers. And these atolls, as you may or may not know, they are sort of related in their evolution to volcanoes, which was originally proposed by Darwin as Darwin's subsidence model. So he described the sinking of the volcano and then the formation of coral reefs around these volcanoes that continue to grow upward, whereas the volcano cooled, increases in density, and slowly sinks. But what I really want to emphasize in Darwin's subsidence model, that it's also describing, in a way, a transformation process. A volcano is a geologic, a basaltic rock structure, inanimate rock. But the coral reef and the atoll towards the right side of this end is really a biogenic structure. The whole coral reef is a live ecosystem that continues to grow upward. And I say this a bit provocatively, but a volcanic island is really mostly inanimate rock with a little bit of biofilm on top of it, whereas the atoll in itself is a biogenic structure. And what's also missing in this depiction of Darwin's subsidence model is the timescale that we're looking at here. Because it sort of creates the illusion that it's a very linear process, and the atolls are sort of the penultimate stage shortly before these islands disappear. But some of these atolls, not all, but some of these atolls have been around for many million years. And if we sort of accept that these atolls are in a way a biogenic structure, a live ecosystem, they're actually among the world's oldest living ecosystems. So atolls like Eniwetok or the Maldives, they're dated back as far as 50 million years ago. And I mean, this is, of course, this is not a pinpoint accurate, but by the order of magnitude, Amazon rainforest is dated at around 55 million years. So if you're not yet convinced that these atolls should be thought of as large living ecosystems, I hope I can change this throughout the talk. I want to emphasize here, this is really very old structures that we're finding in the tropical oceans. But what's also overlooked, and I think what's quite important to really understand the biogeography and the ecology of atolls, is that this depiction of Darwin's model creates a sort of false linearity, or an image of a false linearity, suggesting that it just goes from the volcano to the atoll and then the atoll drowns and disappears. So to start with, I really want to go through the geoecological history and sort of revisit it in a bit more detail, because I think it's important to understand a lot of the properties and processes that we find on atolls. And obviously what's quite important when we really want to appreciate the history of atolls, it's a low-lying structure. So the sea level fluctuations over the millions of years, or even just in the last 500,000 years, they obviously become extremely important to understand what's going on these atolls. And you probably know that just in the last 500,000 years, we had these Brunner cycles with the glacial periods where sea levels rose and dropped by over 100 meters. And this is obviously quite important when we think of atolls and how they behave and how species assembled on these systems. So we had phases of rapid sea level rise where these atoll structures more or less completely submerged. The coral reefs remained, but the island sort of got wiped clean and reset. But either during phases of receding sea levels or stagnating sea levels, the coral reefs were able to catch up with these rapid rising sea levels, and slowly grew upward towards the sea surface. Once the atoll then or the coral reef sort of hit the sea surface, they transition from a vertical growth to a more horizontal growth and built these extensive reef flat plates. And these reef flat plates are sort of the nucleation sites, the starting sites where the islands formed. And this is the sort of the configuration that we're seeing atolls today. But obviously over the history, or over the tens or hundred thousands of years, sea levels eventually started to drop again, and these islands, these volcanic, these coral reef structures became more and more exposed again, until the lagoon completely sealed off, and we had, in a way, these large coralline cylinders sticking out of the ocean, sometimes 20, 30, 40 meters in elevation. But because we're speaking here about a calcium carbonate structure, they're very susceptible to erosion. So during these phases of sea level low stands, these basaltic cylinder structures, in a way, these Makatea type islands named after Makatea in Polynesia, they eroded quite a bit by several meters, up to 10, 20 meters over these low stand cycles. And eventually sea level rise also caught up with the next deglaciation period, and the atoll eventually submerged again. And if I bring back these sea level curves just over the last 500,000 years, you're seeing that these curves, these cycles, or these periods of sea level rise and sea level falls didn't just happen once. So the process that we're really describing here is a circular process in which these atolls move through between being submerged, reappearing, becoming these high-standing structures, and then eventually slowly disappearing again. So these atolls really persist in these geoecological cycles between being exposed, entirely submerged, or just being in this rim configuration that we're having. Another important feature that becomes clear when we appreciate this history is that the atoll islands that we're seeing today are extremely young. And I'm going to talk about this in a bit more detail. We also need to appreciate that atoll islands are really just these low-lying deposits that sit on these reef flat plates. And I already teased this a little bit. The atolls, I think we really need to think of them as large biogenic structures. And so for the next part of my talk, I want to go through these features of atolls and really show how important they are to appreciate them and acknowledge them to really understand the system. So when I say atolls persist in these geoecological cycles, sure, we have the evidence of sea level rise and sea level falls, but what can we say about the ecology, the biology, or the biogeography when these atolls are basically repeatedly reset in their species assembly. So do we have any evidence of what I would maybe call the ghost of past emergences? Well, we do. Especially in the 1960s and 1970s, research groups drilled very deep into the carbonate soils of atolls, and they were able to extract ancient pollen from as old as 5 million years ago from these deep layers of the atoll. And what they found there in terms of plant communities is quite remarkable in a way that these are also the plant species that we're finding today on atolls. But I mean, on the other hand, you could also argue, sure, I mean, maybe the pool of colonization is just very limited. So it's not that surprising that always the same species seem to have colonized these atolls, despite these repeated ecological resets that the islands experienced. Well, we have also some evidence from land snails. And again, what we're finding in several land snail groups on an atoll is essentially the colonization of the same set of land snail species in the last 3 emergence cycles. So these land snails must have colonized the atoll. The atoll eventually submerged, got reset ecologically, reappeared, and the same set of species seem to have colonized again. An even more impressive example is the Aldabra atoll giant tortoise. Again, for this giant tortoise, we have bone records that show that this species must have colonized Aldabra atoll, which is in the Seychelles, at least 3 times in these last emergence and submergence cycles. To me, the most fascinating story of repeated colonization, and not just repeated colonization, is the case of the Aldabra atoll rail. This is, as the name suggests, an endemic rail, sometimes considered endemic species, sometimes considered endemic subspecies, that occurs on Aldabra atoll. And this bird colonized Aldabra atoll in the Pleistocene from Madagascar, where it still maintains a volant, like a flight-able population. It colonized Aldabra atoll, and it did what every rail does, or most rails do when they reach an island. It evolved towards flightlessness. But about 130,000 years ago, Aldabra completely submerged, and this bird went extinct on Aldabra. But after Aldabra re-emerged about 120,000 years ago, the same rail from Madagascar colonized Aldabra again, and again evolved on a trajectory towards flightlessness. So these are the bone records from the extant species, and this is the bone record from the Pleistocene species. So a very unique so far, but a fascinating system to think about repeated colonization or even evolutionary trajectories that atolls, I think, atoll islands offer a window to study in. And in a broader sense, there's this ongoing debate between contingency and predictability. On the one hand, arguments that saying the history of life is dependent on the series of events that took place until that moment. The predictability argument saying universal chemical and physical laws determine very similar best fit solutions under the same environmental conditions. And I mean, I'm not saying that atolls are perfectly making a case for one side or the other, but I think it's just, I just like to think about what atolls and these paleontological records suggest about evolutionary trajectories. So atolls persist in these cycles. And at least from the data that we have, it appears that the assembly and evolution over these cycles is at least non-random. That's how far I would go to say here. The second point that I want to talk about is that atolls are extremely young islands. So if I zoom in a little bit more in the sea level curve, this is just the last 20,000 years, we had a phase of rapid sea level rise, which essentially submerged most atolls that we have. And only in the last somewhere between 10,000 years, the atolls caught up in their coral reef growth. And actually most of the atoll islands that we find today are somewhere between 1 to 7,000 years old. So atoll islands are by several orders of magnitude the youngest, at least oceanic island ecosystems that we have in the world. And just to put this into perspective, Göbekli Tepe, one of the oldest known human structures, about 10,000 years old. So humans were already building or forming societies and building sort of very ancient structures when most of the atolls were still not around. So just to think about how young these atoll islands are that we're seeing. And for the biogeographers if you have some biogeography thinking, I mean, atolls are often explained to be very low in species because they're sort of positioned here towards the end of the general dynamic model. But I would argue we should rather put the atolls here at the beginning. They're just emerged. They're just a few thousand years old. So obviously there can't be much speciation or more complex life communities existing. So sort of atolls seem to be this supertramps paradise, and this is what we're finding in the communities, whether it's plants, insects, or larger vertebrate groups. But I began compiling a large data set on atoll species communities, and what I begin to realize is that there's actually quite a lot of endemic subspecies on these atolls, on the islands, which to me suggests, and there should be a big question mark here, that atolls are really at the beginning of a very early subspeciation process, at least in some of these species groups. But I mean, apart from this observation that we're having these endemic subspecies on atolls, this hasn't been much recognized. But sort of for this hypothesis that maybe it's the time, not the uniformity that restrict the atoll speciation, I think an interesting argument comes from Aldabra Atoll. Aldabra Atoll is slightly uplifted, 6 to 8 meters, so it escaped the Holocene sort of ecological reset, the Holocene submergence. So Aldabra Atoll is not just one of few thousand years old. Aldabra Atoll's islands are about 120,000 years old. And if we look at the species communities there, we see that there's about 43% single island endemism in the spiders, and this goes throughout the different species groups there. So this is sort of what I'm quite excited to start looking into in more detail over the next years. With a colleague from Naturalis, we want to sort of, with very powerful evolutionary models, we want to better understand what the trajectory of speciation on these atolls is, if we consider that they're sort of cycling through these periods and the land areas are contracting and expanding. So this was quite biogeography dependent. But then I want to focus and look a little bit on this fact that these islands are really just low-lying deposits. And what I want to do with you is essentially just take a slice through such an atoll island. And if we cut through an atoll island like this, we really see that these islands, these sediment deposits, they just sit on this consolidated layer of the reef flat plate or of these Pleistocene structure. And there is some zonation also there, which I'm not going into. But what I really want to argue that these are really just unconsolidated sediment deposits that more or less sit there. And that makes these islands very dynamic, naturally very dynamic systems. There's a series of fantastic studies by my colleague Paul Kench from Singapore University, who studied the dynamism of these atoll islands. And he really shows that these islands are wandering. They're moving around over the reef flat plate and constantly adjusting their size and position in relation to oceanographic forcing. But they're not just on a random path movement, these islands. These islands are also, at least in areas where we have strong seasonality and predictable seasonality, these islands are also quite predictably bouncing back and forth. So in the Maldives, for example, we have a very pronounced east and west monsoon. And if we would look on an island from January to January, it would appear relatively stable. But over one season, this island can shift by 20, 30, sometimes 40 meters back and forth by the forcing of the different predominant wind and wave directions. So these islands are also, in a way, bouncing, at least if we have these very strong seasonal effects. Even more important, though, is that the nature of these atoll islands is the nature of growing. And tracking many satellite images, we're seeing that these atoll islands are growing and accreting sediment. And many islands that, for example, got hit by a massive cyclone continue to aggregate sediment and continue to grow. And I want to look a bit more into detail into this process, how to grow an atoll island. This is obviously a very complex biophysical process, but I want to emphasize 3 elements here that we have, and this is cyclones, the corals, and the forest. The corals sort of generate the sediments that we have that built these islands, but we often need these high energy events to move the sediments from the coral reef onto these nucleation or these deposition sites. And the forests are playing quite an important role in trapping these sediments. So even though that we think often as cyclones as a very erosive or a destructive force, what we're finding for at least under certain conditions on atolls is that after hurricane events are actually pulsing a lot of sediments onto these islands or towards these islands and allow the island form to grow. And the important role of the forest is not really recognized so far. There's one fantastic study done by David Stoddard, who's one of the legends in atoll ecology. And he tracked the cyclone impact of an atoll and showed that the islands of the atoll that had a very stratified native vegetation, after the cyclone hit this atoll, the forest there was able to bind and trap the sediment. And after the cyclone had passed, the islands with the native stratified vegetation had grown by up to 1.5 meters vertically. In the same atoll, the islands that were either completely deforested or were turned into these monoculture coconut plantations, these were these islands that suffered severe erosion. So it's really this, it seems to be this interplay between the corals, but also the forest to bind the sediments and help this growing process of these islands. And if you would dig into the ground of an atoll, and unfortunately, this is really only the best image that there is in the literature. These islands sort of have growth rings because we have these periods of overwash when sediments are getting deposited on these islands. And then we have periods of relative stability when soil starts to build up until eventually, sooner or later, the next cyclone or high energy event deposits the next layer of coralline sediments. And then soil builds up. So we're seeing in these soil profiles, we're often seeing these layers of buried soil and coral deposits stacked on top of each other that in a way document the growing of these atoll islands. So atoll islands are very low-lying and dynamic systems. And even on the scale of a single atoll, we're experiencing that the different atolls relative in their position to these dominant forces can be quite differently affected. And that makes also the terrestrial communities on these atolls very dynamic. So rather than thinking, these atoll islands are often presented as being always the replicas of the same community, but depending on the exposure of the island and the relative position of these islands, we're seeing different assembly points of the community that are either always trapped in a very early succession stage because this island gets overwashed every few years, whereas other islands within the atoll are possible to achieve a higher succession. And we sort of showed this in a global study where we tracked the species turnover within atolls, and we can show that the atolls that experience higher cyclone impacts are also the atolls that are more dissimilar in their species community between the different islands. So it just really shows how important these high energy events not only are for the geosphere part, but also for the assembly of the biosphere part. The last talking point about atolls is that these are really biogenic structures, which I already teased it a little bit. So atolls can be these impressively vibrant live ecosystems. But we often fail to really acknowledge that at the right scale because we're so obsessed by either the island or either the corals or one part. But I think Francis Rogerie put it very nice. He said the atoll is the singularity within the oceanic tropical desert. And what he means by this, we really need to look at the whole structure and really understand the connection of the whole structure to appreciate how these systems come about. And seabirds are playing an important role in that, that when we start with an island, a barren island, it's just calcium carbonate sediments. So there's no nutrients, there's no minerals there except for calcium carbonate and a little bit of magnesium. So these seabirds are really important as catalyzers to the carbon sequestration. But it's not just the seabird, it's also the forests themselves that are not just the passive receivers of these nutrients, but they also contribute in actively enriching the atolls. And a very important, or probably the most important atoll plant is Pisonia grandis. This is a fantastic Pisonia tree, over 4 meters in diameter, that I photographed a couple of weeks ago in the Maldives. And there's a very peculiar phenomenon with atoll forests, is that in many settings, atoll forests tend to converge towards monodominance of Pisonia forests, which I think in itself is quite remarkable. Most tropical forests converge in their maturity to a very diverse setting, but on these atolls, there seems to be this conversion towards Pisonia monodominance. And these Pisonia forests, they interact in a very fascinating way with these seabirds. These seabirds bring in large amounts of nutrients in the form of guano, bird poop essentially. But the sort of the issue that we're having is that because we're just having a calcium carbonate sediment, the soil is very alkaline. So particularly the phosphorus is sort of locked away and can't really enrich the soil. And this is where the Pisonia comes into play, because Pisonia leaves are extremely acidic. So what Pisonia does, or these Pisonia forests do, is they lower the soil pH to a degree that the phosphorus can be leached out of the guano and enrich the underlying soil with phosphorus. But as the phosphorus or the guano percolates into deeper layers, the pH increases until the phosphorus remineralizes and forms these apatite layers. And this is a specific rock formation that is actually called atoll phosphate rock, that is probably formed through this interplay of seabirds and these Pisonia forests. And we're sort of seeing this in some studies that looked at the soils of atolls, that even if we have a native forest like a pandanus, the phosphorus enrichment is really located or concentrated to the areas where we have not only the seabirds, but these Pisonia forests. But as I said, these atolls are connected systems, so it's obviously not stopping here. We're seeing an enrichment in these native forests where we have lots of forests and also Pisonia. We're seeing an enrichment of the groundwater lens as well with nitrogen and phosphorus. And the groundwater lens is in a very constant exchange with the lagoon. It's quite important. There's no groundwater discharge towards the ocean side of most atolls. It's only going to the lagoon side. So that's quite important when we want to understand the larger energy and nutrient flows. So the groundwater discharge is essentially during high tides or during swells. The groundwater lens nags a little, the lagoon water nags a little bit away from the groundwater lens and pulls these nutrients into the lagoon environment. And in these lagoons, we're meeting a phenomenon that's called lagoon pumping or atoll flushing. Because atoll form these rings, they're relatively sheltered towards the open ocean. And what that means is that when we have pronounced tidal cycles, the tidal water levels rise and fall faster outside the atoll than inside. So after the high tide, the water levels drop faster outside the atoll than inside. And what happens is, therefore, we have a very directed outward flow of this lagoon-enriched water across the reef crest into the nearshore pelagic environment. And the opposite then happens when the water levels start to rise again with rising tides. The tides rise faster, the water level rises faster outside the atoll than inside. So we're getting this inward directed flow of water again across the reef crest. And obviously the amount of water that is getting pumped or flushed depends highly on the openness or the closedness of the lagoon. And on the volume, but still there's large amounts of nitrogen, phosphorus, and other compounds get pumped in and out of the atoll. And some authors actually call this the breathing of the atoll, which I think is quite a imaginative but nice picture to imagine how these atolls pump water across the reef crest. And what we're observing outside the atoll is a phenomenon called the island mass effect, although I want to argue that we should call it very specifically the atoll mass effect. So we are getting upwelling around most oceanic islands of deep sea and nutrient-enriched deep sea waters that gets upwelled on the outside of the atoll and already leads to some enrichment of the nearshore environment. But this upwelled water in the situation of atolls then also meets these further enriched nutrients that get flushed, that get pumped out of the lagoon, and they create a highly productive nearshore environment. This is sort of and sometimes quantified by 130% increase in nutrients. And in false color images, we can really see this enrichment. This is the Maldivian Maldivian atoll chain, and we're seeing here, at least during parts of the season, that massive upwelling events lead to this bloom and enrichment in chlorophyll around the Maldivian atolls. The most peculiar phenomenon of atolls and the energy flows is that there's not only just an upwelling outside the atoll, but we're also having what's called an endo-upwelling. This is a phenomenon that's poorly understood and probably not that relevant, but I think it's definitely occurring and quite interesting. So deep sea oceanic waters at somewhere around 800 to 1200 meters depth enters this porous carbon limestone of atolls and gets also upwelled internally through the limestone structure and then exits the atoll at the surface. And as I said, it's very contested how much this really contributes to the significance of the energy flows, but it's a very fascinating system. And you probably, or you may or may not know that on a lot of atolls, we have these freshwater or brackish water lakes where we find stromatolites. These very ancient life forms are quite dominant in these systems. And these stromatolites, they have been identified as one of these recipients of these endo-upwelling processes. Again, are they absolutely dependent on it? Hard to say, probably not. So pulling all this together, and this is a preliminary figure, I'm still working with the illustrator, so apologies for that. But pulling all that together, I really want to argue that we have to approach these atolls as these integrated, also transboundary systems where energy and nutrient flows are crossing so many times these classic boundaries that most of us have in our head between terrestrial and marine, or photic zone and deep water zone. So we have the upwelling, we have the process of these seabirds, and then the flushing of the atoll. So far, in the first part of this talk, I have argued how these atolls are sort of a fascinating ecosystem in itself, whether or not you're convinced by that. But what is their wider place in the biosphere? What's the role of the atolls in the wider biosphere, at least in the Indo-Pacific scale? So we've done a global study where we predicted and calculated the global seabird populations that are nesting on all the atolls of the Indo-Pacific. And what we found is that, or what we realized if we add up the seabird colonies on all the Indo-Pacific islands, is that there's more seabirds on the 280 atolls than there are in all of Europe. And then there's also more seabirds than there are seabirds in all of South America. So these tropical atolls, even though they're not species rich, for these tropical seabirds, they are a hotspot of global significance, with over 31 million seabirds on these atolls. And obviously, as I already argued, these seabirds are very important nutrient pumps. So related to this concentration of seabirds on these tiny speckles of land across the Indo-Pacific, they are probably very important as nutrient delivery systems and for the ammonia emissions. And after all, we simulated in this study also the foraging ranges and show that these seabirds forage over vast areas around of atolls. So they highly concentrate and focus nutrients on the atoll environment. Also, in another project that I'm currently working on, we started to simulate the movement of animals, or not just animals, of species across the Indo-Pacific islandscape. And we're sort of assessing and measuring how important are atolls as wider stepping stones for the colonization and also for maintaining the connectivity between populations. And this is an ongoing project that we're still working on, but it already seems as if atolls are quite important in maintaining, for some species groups, the wider connectivity across the Indo-Pacific, because oftentimes these high islands, volcanic islands, they form these isolated clusters, but we have these long chains of atolls that are probably quite important stepping stones. Maybe not today when these islands are in these low-lying ring configurations, but if we think in larger evolutionary scales, when these islands are exposed during sea level low stands, they have huge land areas. The entire lagoon becomes land. So at that time, they probably become, or during these phases, they probably become quite important stepping stones. I'm not going too much into detail to that, but I also want to emphasize, of course, that atolls also carry a unique cultural heritage. There's many indigenous cultures on atolls, whole atoll nations. Even the word atoll itself comes from the Divehi word. Divehi is the language spoken in the Maldives. So even the word atoll itself is derived directly from a traditional atoll culture, human culture, and these obviously carry very fascinating and unique knowledge about these systems because they essentially co-evolved. So turning a little bit more now away from the ecology into the future and approach to atolls in the future, I think it's quite problematic actually the way we think about this system, because it seems like our approach to atolls is mostly bound in this doom and gloom narrative. And colleagues John Barnett and Jerry Liu, they put together sort of a buzzword analysis of how atolls are being framed, and we can see about that it's mostly about migration and their sort of the reduction to their smallness, which I think is not doing justice to these atolls as systems. There's also quite a problematic dynamic in there, I think, that sort of all that we discuss is whether we translocate the population on atolls to country A, B, or C. So this is largely where we're bound in our discussion or our approach of atolls in the future. So in a way, these atolls, and I want to argue, or we argue in this article here, is they're sort of became, in a way, the canary bird for a lot of climate change models. Whenever we want to say how devastating climate change impact would, it seems quite handy to have the atolls and refer that these atolls will be gone at a certain number of time or after a certain amount of sea level rise. So what we argue, or what I want to argue in this group of authors, we sort of proposed a rethinking of these atolls, and we argue that there are place and nature-based opportunities for atolls to build local resilience. And the key to unlock these place and nature-based opportunities for atolls partly lies in what I just presented to you. They're not small islands. We shouldn't just reduce them to their smallness. We need to recognize atolls as these large transboundary systems that integrate the marine, that integrate the freshwater, and they integrate these terrestrial subsystems in this large ecosystem in itself. And we also need to recognize atolls as these biogenic structures. The nature of an atoll is the nature of growing, not one of eroding. And what we're sort of arguing is that there are these three components to the atoll that we need to maintain, or that we need to study. That is, sort of the coral reefs are serving as the sediment factory that produces the sediments for the islands. We need the open connection, sort of the conveyor belt of the sediments from the reefs to the islands, and then the islands themselves also need to be in a state that they can hold and trap and bind these sediments. And of course, climate change is a major issue there. With ocean warming, ocean acidification, damaging these impacts. But we're sort of overlooking that in this debate, that there's a lot of local scale impacts that are much more manageable on a local scale with local communities, that also contribute to the stability or to the erosion of these atoll islands. And even if without sea level rise, if the coral reefs are entirely destroyed, these islands completely denuded, they're also transitioning probably away from this accretionary nature to an erosive nature. So we argue that there are a lot of these local impacts that we can go to with ecological restoration to study and understand if that contributes. And earlier I mentioned this case study that showed the negative impact that these coconut plantations apparently had for the stability of these islands. So in a recent study that was led by the Nature Conservancy and Mike Burnett from the University of Santa Barbara, we mapped out the extent of these copra plantations, these coconut plantations across the Pacific, to really understand what's the scale, what's the issue that we're talking here about. And what we found is that about over 60% of the atoll broadleaf forests have been turned into coconut plantations. And what's quite important here to emphasize is that many of these copra plantations are no longer actively used. So they just sit there, they're sort of locked in this ecological state, but they're not actively used anymore. And just to put this into perspective, it's estimated about 39% of the Bornean rainforest has been turned into crop palm plantations. So just to give you a relative reference, what the scale of this palm impact is for the stability for the wider atolls. But I think there's many exciting opportunities coming in the future to understand more what these crop or these monoculture plantations are doing for the wider stability for atolls. So what we're really arguing, and I mean, I would love to stand here and give you sort of a presentation, the 10 golden rules, how to restore an atoll. I would absolutely love that if we were there, but we're not. So what we're arguing is that we need to identify now as researchers, we need to identify where are these interactions between the geosphere and the biosphere of the atoll? Where are they interacting, and where are the opportunities that we can go in to restore biosphere processes that then cascade towards these geospherical processes? So this is sort of the way I think how we can unlock these place-based management opportunities. And this is not to say that reducing greenhouse gas emissions and lowering these global impacts of climate change is absolutely essential, but there's much more that we can do also on a local scale. For now, mostly from the research perspective, but hopefully we're getting there to really understand the ecological benefits that then can translate from research to action. So to slowly come to an end with this presentation, I really want to emphasize or present to you this rethinking of atolls. Atolls are these integrated transboundary biogenic systems that need to be stewarded by the local communities and not just simply surrender to climate change. And I haven't spoken much about it, but I think traditional ecological knowledge, and I'm happy afterwards to speak a little bit more about that, I think is an important key to unlock a more systems integrating approach to atolls. And I want to end this presentation with a slightly more colorful image, maybe to stimulate your rethinking about atolls. The oceanographer Isaacs wrote in his opening remarks of his book, he essentially asked, why are there no pelagic forests in the ocean? One can easily compute the advantages such a tree would enjoy with its canopy near the surface in the lighted levels and its trunk and roots extending down to the nutrient-rich waters under the mixed layer. Well, what I'm sort of suggesting is maybe these pelagic forests exist. We just gave them a different name and really didn't recognize them as such so far. Thank you.
Any questions? And there's fantastic imagery as always. Okay, we can open up to questions. I'll kick off while people are thinking. You mentioned the sea level rise and able to accommodate that. Is there an idea on the limits? What rate of sea level rise proves too challenging even for fully flourishing biogenic atolls?
That's a good question. I'm not sure. I mean, there's so many factors coming in, because when you build these models that lead to higher sea level rise, then related to that is higher sea surface temperatures. So that always then cascades into the coral reefs. So I'm not aware that there's this clear cut where we're saying yes or no, thumb up and down, to what degree it's possible. Yeah.
Okay. Great. Okay.
I always know I'm going to ask a question and I always hide in the corner of the room. Thank you very much, Sebastian, for the presentation. Very, very, very good.
That's only for online, so just speak loudly.
Oh, sorry about this. Thank you very much for the presentation. Wonderful job, and incredibly sensitive ecosystems. Fantastic. Yes. So I'm not so sure it's so much about the question. So my entire background is about risk and on multiple facets of risk. And now you've been mentioning, now you told this fantastic, beautiful story of the geological evolution of these environments. They are almost like a nature gift for us. And they're so like a little jewels in the ocean that we could celebrate, but they also so incredibly fragile. So on the scale of pre-human, it does look like the system itself will survive. It's just how we gonna celebrate that in our life as humans, and for how long and in what form, that depends on our own action. And when you touched on the local scale of response to what is to come from the climate perspective, it made me immediately think about the amount of work that could be put into looking into the vulnerability dimension of that risk. So we understand where they are, we understand what they are, we understand climatically. I find me after we could talk about the sea level rise and the risk. I could even give you projections and all sorts of them. But it's the vulnerability that always remains like a big open question. So it's a local vulnerability of the community that can be there, and also the ecosystem itself. So I was just wondering if you want to put a little bit more weight and strength in these couple of slides that can cover that aspect a little bit more, because that's ultimately where the response and adaptation of these systems will be hiding. And sorry about long question.
So I'm not sure if I understand. So the vulnerability of local communities.
And the system itself, so the vulnerability of the atolls, like how would you define it, and which dimensions of vulnerability would you put more weight and emphasis on?
I mean, essentially the coral reefs, because they built the fundament of the whole system, and they generate the sediments of the islands. They are the structural framework. So the coral reefs are certainly, if we trace it down, the core point where the vulnerability of these systems sits. Yeah, if that answers your question.
Okay,
Maybe we can take it afterwards.
Thank you. Very nice talk. Thank you, Sebastian. You've placed a lot of emphasis on the importance of seabirds correctly.
Mm-hmm.
Placed a lot of emphasis on the importance of seabirds bringing nutrients onto the islands and being distributed throughout the atoll ecosystem. Are you giving consideration also to dolphins, particularly spinner dolphins, which import probably comparable levels of nutrients into the atoll lagoon on a daily basis?
Yeah, definitely. I mean, that's a good question. So the seabirds are not the cause for high productivity, they're symptoms of high productivity. And in the same way, other marine megafauna that is using high upwelling events or enriched waters, they could also contribute. And I know about a study from Palmyra that also showed that the pelagic sharks are also important nutrient delivery systems into these atolls. For many other species, I'm not aware that it has been quantified. But I think everything mobile that's connecting these productive areas with the nearshore environment has the potential to transport nutrients at relevant scales or at relevant amounts into the atoll environment. Absolutely.
It's quite a striking statement. Is there evidence that the flux on dolphins or sharks is as large as seabirds?
I don't know how precise. That's okay. Yeah, I don't know how precise the comparison is, but the atoll behind you, the odd-shaped one, the L-shaped one, Varv Atoll, in the Maldives, that has the longest reef in the Maldives, and spinner dolphins, which occur in large numbers around atolls throughout the Indo-Pacific, migrate on a daily basis in and out of the atolls. And Varv Atoll I mentioned because they can pass through the channels. They don't go over the reef flat, of course. They go through the reef channels. And where you have a long reef, fewer channels, they get concentrated there. So very large numbers of spinner dolphins passing in and out through these particular channels on a daily basis. They feed at night offshore in the mesopelagic boundary layer, which is a symptom of the island mass effect, the atoll mass effect. And in the case of the Maldives, with the seasonally alternating monsoon winds driving seasonally oscillating monsoon currents, brings clear oceanic water to the upstream side of the Maldives. And because of the solar radiation, the upper layer is heated, it's stratified, it sits on top of the deep nutrient-rich water. But when it hits this brick wall of the Maldives, you get upwelling, bringing nutrients to the surface. So a physical process of bringing nutrients to the surface, which drives the plankton bloom, phytoplankton bloom, as we saw on the downstream side. And then the seabirds and the other megafauna exploiting this and returning those nutrients to the atoll lagoon. So many things going on. It's
absolutely.
It's a dynamic, complex process, but and seabirds very important. Just pointing out the other.
Absolutely,
other parts of the system as well.
Seabirds are, I think, just in their deposition rates, and they're just a bit more easy to quantify than the dolphins. But I'd absolutely agree that this is probably also an important connector or delivery system into the atolls. Yeah.
Thanks. Could you say more about sand keys and why they're stuck in a relatively early successional state? Are they sinking faster or more recently exposed? And are they as resilient as true atolls to sea level rise?
Sorry, which?
Sand cays, things like Bramble Cay.
Yeah. No, I can't say. I can't say much about them. It's an interesting question to think about, because we oftentimes lump all these reef islands together in the same category. If we really pull together this atoll metabolism, it really suggests that having a lagoon is quite important to have this nearshore productivity. But I don't think anyone had looked what having a lagoon in the case of a proper atoll does to the larger energy fluxes compared to just having these cays that exist without these. So it's an interesting question that I also thought about, but that I'm not aware of has been disentangled or looked at.
That was really nice. So I was just wondering, when you said, and I know that atolls are are really well connected. They're connected systems, which is just so interesting in itself. But I was just wondering about the levels of endemism and at what scale you get endemism, and amongst which groups and why. And is it anagenesis, cladogenesis, and also whether at the same kind of the flip side of that, to what are the patterns of invasion on the island? Sorry, that was a lot.
So in terms of the endemism, we're getting both. We definitely It seems to be biased towards the atolls that escape the Holocene submergence. So we have endemic species in the Kiribati, on Kiribati Atoll, which has probably escaped the Holocene submergence, the Holocene reset. We have it on Aldabra. So these systems, and from the genetics studies that exist, suggest that this is really internal speciation. We're also having situations like the Laysan duck and Laysan Atoll that by now I think we're quite confident that there's bone records of this species also in the high islands where it went extinct, but it sort of survived there. So we're getting both. The bias definitely seems to, for full species and endemism, seems to be on these atolls that escaped the Holocene, that are about 120,000 years old, not just a few thousand. But then still we're also seeing on atolls like even Cocos Keeling or the Maldives, and yeah, we're also seeing these endemic subspecies there. And I can't comment much on this now, but I'm still pulling together this. But together with Luis Valente, we want to use the DAISY model to sort of look into these processes. In terms of invasive species, I mean, it's the common ones, invasive rats, particularly. Most atolls have been turned. I mean, atolls have quite a brutal history, from being turned into copra plantations, being sites of nuclear testing. Not all, of course, but I think a lot of them, specifically in the Pacific, were turned into military bases. So humans have been bringing, I would say, the classic invasives: yellow crazy ants, rats, certain weeds. Yeah.
Hello, thank you so much for your incredible talk. I work with seabirds in the Atlantic, so a little bit.
Awesome.
But in Brazil, where I work with seabirds in Oceanic Islands, we have only one atoll, which is Rocas Atoll. Yeah. And my question is regarding the sensitivity of atolls related to their age, like geological age. The younger the atoll, more sensitive it would be for climate change and sea level rise. I would like to understand a little bit about that, because we don't have forests in the Rocas Atoll, for example. Does it make, probably it's a really recent atoll because it doesn't have endemic species, no forest, and is it more prone to be impacted by ocean level? That's my question.
I mean,
thank you.
Yeah, so there's one of the major drivers for species diversity on atolls seems to be rainfall, and we're having very pronounced rainfall gradients on these atolls. So I would assume very arid atolls, and I'm not sure if that's the case for Rocas, but the water lens is generally quite small, so there might just not be enough water to sustain these systems. Like I said, So I think that's probably a contributor there for rockers, without knowing much more details about the biogeography, so to say.
I'm very intrigued by this formulation of these as sort of these bioecological systems. Well, we've talked biogeological systems. We've talked quite a lot about that, and I wonder how more widespread these examples are in the natural world. The atoll is a nice example of a relatively self-contained system where you can see this interaction between a biogenic system building on top of a geological one, and then the two still working, being maintained by this flow of nutrients and sediments between the two. Is this an interesting case study in itself, or does it have wider lessons for in terms of other ecosystems?
That's a good question. I mean, there are islands that are built, I think, around Florida that are built by snail shells. So in a way, it's also like a biogenic structure that, or biogenic material, like the corals that build the sediments. In a wider, some islands are, I mean, not. I don't know too many other examples, but it's an interesting thought.
I suspect they're out there. We just have to look at them in their framing, and things will pop out there. But really, really interesting.
Yeah. I mean, I guess whenever you have a lot of deposition and sort of build-up of material, if there's some analogy to the atolls in this, I don't know, could be.
Yes, yeah, and there's feedback loops as well. Okay. Great. Okay. Thank you. It was absolutely fascinating, and it's always lovely to see such beautiful imagery as well. So we have drinks there, so do feel free to linger for some informal conversation as well. So and thank you once again, Sebastian.
Thank you.
Yes.